sure you know. Okay, what do we think? What do we get? Shall I share with Henry?
1.
1. Do we agree, disagree? No idea. What happened to everyone's thumbs? Well, okay. A lot of us don't know, right? There's an easy way to tell, right? I can go into here, I can just type in node, and then I can actually do node, and I can say 1 modulo 8, and it's 1. Right? How many times does 8 go into 1? 0 times. So how many will be left over? 1. All right, let's do another one. 19 modulo 8. All right, so quick, talk with your partner. All right, who thinks they know? Yeah, Shia? 3? Why?
Because 18 into 19 only gives you 2, and then you'll have a remainder of 3.
That's right. So 8 goes into 19 2 times. So that would give us, evenly goes 16, right? 19 minus 6, 3. Does that make sense, that math? It's a little tricky, but okay. Seems like we're getting it all right. Anything else for values, types, and operators that we talked about? Truthy and falsy, right? So we talked about not just true and false, but truthy and falsy, right? Okay, great. So if I were to enter cat and dog, take a second with your person next to you and tell me what will be the return value of this. All right, clap your hands once if you hear my voice. Clap your hands twice. Okay, what do we think? Somebody, yeah, David. Dog, why? Okay, great. So he says for an AND statement, it's going to check both sides. Is that essentially what you said, right? So he says dog is going to come out. So we do get dog because it's going to look at cat. Cat is a truthy value in JavaScript, but it has to check to see if the other side is also truthy. And so it gives us back dog because dog was the last thing that it checked. So what if I do cat and do we know our falsy values of JavaScript yet? All right, hang on. So we have falsy values. Who wants to give me 1? 0. Henry, 0. No, empty string. Isaiah? False. False. Classic. Marvin? Null. Okay. Danielle? No. Not a number. NaN. Digging it. What else? Undefined. Excellent hand. Undefined. Anything else? Good. Don't worry. 1, 2, 3, 4, 5, 6. How many are there? Are there 6? Yeah, there's essentially 6. Some books you read will also say -0. That's like, depends on what book you read, but 0 is 0. So, I don't know. We'll be mostly just focusing on 6. But don't be weirded out if you sometimes see something that says -0. Okay, so we know our falsy values. Brilliant. So if I say, and null, talk to your neighbor really quick and tell me what is going to print. All right, back. Someone I haven't heard from. Next class I'll bring a random name generator, but for today, what do we think? Someone I haven't heard from. Sin. No? Why?
Basically,
That's right. Yep. Okay, so he says it's going to give us back null. First thing it's going to do is check the left side. It's going to see cat, which is truthy. So it's going to continue and check the right side and give us back null. Nailed it. Oh, we'll try that. We'll try that in a minute. All right. What about if I say NaN and cat? Quickly take a 15-second. Alrighty then. Grab your hands once you can hear my voice. All right, who wants to share the prediction? Yeah, Calvin.
It would be NaN or llama.
Why?
It's checking the first statement, and if it's false from the beginning, then it just turns out it's false. Right?
Sounds good. All right, so he says, hey, we're going to check the left side. The left side is giving us back false. So we know both sides can't be truthy, so we don't even need to look. Sounds great to me. Let's do this one. This one's for sin, right? So if we say cat or no, what are we going to get back this time? I'll just, if you want to just raise your hand, because I think we're probably right and brown. Cat, why? Great. So Brandon says, hey, or is evaluating that we have at least one truthy value on the side, right? Cat's already true. What's the point of checking the other side, right? It's like if I was looking at my weight and I weighed 150 pounds, I don't need to check if I also weigh 130 pounds, right? I already weigh 150 pounds. I weigh more than that. Thank you very much. All right? So we get cat. How about if I say cat or dog? Marvin, go ahead. Yeah? Yeah, so it's still going to just print that first truth. It's already found its truth. Great. What about if I say 0 or empty string? All right, this one we're not as confident about. Take a few seconds with your person. All right, I can feel that it's quieting down. Somebody new, Kevin Brutus. It's an empty string. How come?
Because when the left side is false, the right side returns empty.
Okay. So he says empty string because when the left side is false, the right side is going to return regardless of whether or not it's true or false. Cool. Yeah, totally. The last thing that it's looked at. How about if I throw in an exclamation point? What are we going to get now? Jay.
You would get not 0 because if it's not 0, then that means it's true.
Is it going to come back as not 0? What is not 0? Interesting. Okay. Henry, you want to take a shot?
Alright. The way I'm reading it is 0 not. Or.
Oh, I probably should put it in the other direction, yeah? You mean it's here, right?
Yeah. Now it changes things.
Yeah, Jay, does that change anything for you?
No.
Oh, okay, you knew what I was talking about. Yeah.
No, but like
Okay.
if you run it, the computer doesn't know what you're
Yeah,
doing.
right. Which Wakabasi? Okay, interesting. Interesting guess. Marvin?
If you put like another exclamation point, it would be like definitely not there.
Interesting. So we don't seem to totally know what the bang operator does. All right, so let's define that. Right. So the bang operator, I'll write it here. It returns a Boolean. Returns a Boolean of opposite value. So what's that mean? What is cat? Cat is a truthy statement, but it's just but it's still just a string cat, yes? But if I do Boolean, or a bang cat, it's going to be the opposite, returns a Boolean. So a Boolean is, we already defined it as true or false, of the opposite value.
True.
So cat is truthy.
No, this is gonna come.
All right, well, we're doing this one first now. I like it.
No, cat is false.
Give an inch, take a mile. What?
Cat is false, man.
Yeah, so cat, this is going to evaluate to false. Does that make sense? So what's zero bang going to give? Yeah, true, right? So this, when we run this, we're actually going to get the Boolean value of true. Because that evaluates first, and that evaluates as that Boolean true. Right, so once we say not zero, that's the equivalent of writing true. Right, and I can prove that. Not zero equal to true. Oh, that's not going to do it. Right, not zero equal to true. Agree, disagree? Right? Agree. Right, and so does the computer, so we know it's correct. Questions on the bang operator? All right. It's called like the bang operator. Yeah.
Basically, it's always true until a false statement.
So it takes whatever the inherent value of something is, whether it's truthy or falsy, and will return the opposite in Boolean form.
No, the whole truth is false. The whole thing.
Right. Every value in JavaScript is truthy except for these. Everything else will.
Together, it's always going to be, if it's both true, and the true is one false, it's going to return. It's reading from the left to right.
Yeah, it's reading from left to right. So what is this going to give me? To hit Marvin's question. Or
So is it like an opposite?
yeah, the opposite of an opposite is what? Is the reality, right? So bang zero, we know evaluates the true. True has a truthy value, so if we bang true, we get the Boolean opposite of true's value, which is truthy, so we get false. So we can essentially see exactly what something is. Questions on that? By the way, I'm writing a node. I got to the screen by just typing a node and hitting enter on my terminal. I can still do Command K to wipe it out, Control C to bring it back to regular terminal. Okay? Okay. I think that's pretty good for value types and operators. Let's talk about variables. What do we know about variables? All right, yeah. So we have const, I heard.
That
And we also have var. Okay. What are the differences between these? Shia?
const is like consistent a consonant.
Constant?
Constant.
Perfect. All right. Constant. Any other differences? What are the other ones? What do we know? J-Fel.
They operate in the same way. They're both variables and can be reassigned.
Okay, I like that. So variables can be reassigned. Maybe it's two S's. I don't know. I can't spell. What else do we know?
So len is actually a variable that you can be reassigned, but var is not longer used since the ES6 was added.
Okay. So, can we reassign the value of const? No. So variable, so these can be reassigned. Constant should not be reassigned. And then You said something about ES6. Which one's ES5? Var, right? So this is ES5. This is ES6 plus. Right? This is what you should be using now. Just don't be freaked out when you see it in var. And const. You should be using these two. You should almost always default to const until your computer complains that you're reassigning it, and then if you need to reassign it, you turn it to let. Questions on that? Or if you know you're going to reassign it, then you can just use let too. So there are some other specific differences that really are important, but probably not important for where we are right now, and that has to do with scoping, which is scoping means where you can actually see the value of these variables. So just something you might want to write down in your notes to see someday later on is that let and const, these are called block scoped. And var is function scoped. So I know that probably doesn't mean a whole lot at the moment, but write it down. Eventually it'll make sense. I'm not going to go into that lesson now. It wouldn't be helpful for us yet, but you definitely will get this by the end. Okay, but that's like the key difference between let and var and like why it's been changed. Is because this is block scope, which will make life better. Anything else we need to know about variables? Not too much, yeah? Any questions on this? Okay. Let's talk about the conditionals. What do we know? If. Okay. I like it's a good start. So we have if, and then what? Yeah, well, there's something else to that if. That's kind of important. J. Jones? Boolean, maybe. What's another word? Condition. So I'm going to use this as condition. I'll just write condition. So, because we don't actually care if it's true or false. We care if it's truthy or false. Does that make sense? Right? So if I say if cat, run this, it's going to run this every single time. Many cats, by the way. Sorry. There's a lot of cat examples throughout this unit. Yeah, right. So that's going to happen. Okay. And the dog will almost always be inferior and everything equal. Okay, so excuse me? Alright, so if condition, then we have a code block, right? So code block, right? Block scope, interesting. What else do we have in our condition? Maybe someone I haven't heard from. We have to check that con, right? I haven't heard from you.
Yeah, you use else statement to be in case of that is false.
Else, yeah. What about what's one in between? Else if, right? If, and we can say else if, we'll do another condition. Code block, and then give it and then else, right? And we can have as many else ifs as we want. Okay, let's make that very clear. We can also have like an if block here, and then another if block, and another if block. But the else if block, else if, and else, this is only going to run one of these code blocks. And else, is there a condition with else? No, right? This is the default behavior. Default block. Sorry for this word. Yeah.
Why would you have like multiple ifs? Like if you can do it that way, why would you do that instead of doing else?
Okay, cool. She says, hey, why have like multiple ifs? That's a great question.
And would it be in the same block?
Would it be in the same block? Okay. Jay, you want to take a stab at it?
If you wanted to remove more than one condition, because this block will only choose one thing, because it's if, or else, versus if would give you if this, and you can also say if that, and you can get two things back, versus just having to choose one.
That's pretty much right. So to sum that up, so if I'm over here, ignore that for now. That's going to be our exercise when we start to review block loops. So let's say I'm up here, and I say, okay, I have some variable, so I'll say const, and I'll have a lucky number, and my lucky number is 13. All right? So then I can do a condition, all right? I could say, hey, if lucky number is greater than 10, console.log, big number. This is just an example. So I could then say, like, if it's smaller than 10, I want to do something, right? I could just say, like, and that's when I would do, like, the else, right? But what if I wanted, like, I didn't care about an else. I only cared if my number was big. So then I don't need an else, right? So I could just do that. What if I did care if the number was even or odd, right? But I didn't actually care about the size of the number. I cared about the size of the number for fun, for one thing, and then I also just cared about even or odd. So I go, okay, so I'll just write another if lucky number modulo 2 is equal to 1. So this is if it's an odd number, which really also could just be abbreviated to that because 1 is a truthy value, but for clarity I'll do that. Oops. Okay. Yikes. Okay. So if it's equal to 1, I'm like operating on such little sleep. But there won't be a difference. You'll see. Okay. So if this is an odd number, I will also console.log choice. Okay. Thank you. Yeah, that section of typing was a mess for some reason. Okay. So I have two entirely separate concepts, so I have two if blocks. That's all. All right, so if I run this in Node, and I say node.index.js, I get big number, odd choice.
So could you do the same thing if you had a or an and statement, or would it be better to do the else if?
It really just depends on like specifically what you're trying to accomplish. So it can mix. Like, what if I only care if it's an odd choice and it's a big number, right? I could say and up here. And then write the same thing that's in the other if, right? I could also just select all of this and move it up, because this way I care if it's a big number, and then on top of that I care if it's a modulus. But if it's a smaller than 10, in this situation I won't be able to access that inner code. So it just depends on what exactly you're trying to get out of it. It's very variable based off of the condition of your code. I hope that clears it up a little. We'll definitely get more practice with that. Okay, any other questions on the if, else if, or else? No. Great. Okay.
A little clear about the what was it called? Ternary operator?
Ternary operator. Sure. So I really don't want us to beat ourselves up over ternary, but I will show you anyway. Ternary is something that should come later. Probably it's slightly less readable, so it's kind of preference. What does a ternary operator look like? All right, let's say I do have an else here, and I say else, and I just want to log console.log small number. Right, so I've got two options. So the ternary. Ternary goes condition. This is the format. Condition. Question mark. So is that true? If it is, do true stuff. Else, do false stuff. Right? That's the format. So in this example, I could say lucky number greater than 10. If it is, I'm going to log this. It's the same opening notice, like Sloop John B by the Beach Boys. To me, it sounds like that. Anyway, do you guys know that song? Sloop John B? You guys don't know the Beach Boys? All right.
Cardi B? No?
What?
Cardi B?
Cardi B?
They only know it's Cardi B.
They only know Cardi B? I don't know about that. Right? This is the same block of code. Right? I can run it and we'll see that it's going to tell us the same thing twice. Big number, big number. Big money, big money. All right? So it's just condition, question mark, do the true thing, else the false thing. That's it. We could write this, I think we could write this even like console.log. Sometimes you can write things like this where I could say lucky number greater than 10, question mark, big number, else small number. Yeah. So, see, you can still like do, like that's technically more efficient, right? But like I said, it's kind of like less readable. But you could do stuff like that because everything in here is going to get evaluated first. So since it's all getting console log, I really might as well write it once and then just do the ternary inside the console log. It's also an option. That's it.
Could you assign that to a variable?
The value of the ternary?
Yeah, so like, could you put the ternary in like let ternary equal and all that?
Yeah, so I could say, let's say I have two variables. I have const num1, and it's equal to something I don't necessarily need to know. And I say const num2, and that's going to be 96, right? And then I could just say, like, if I don't know which one is which, I could say, like, let bigger. All right, I'll just do const. So say, like, const bigger num, and then it would say if num1 or whatever, right, is greater than num2, num1 greater than num2, then do num1. Else num2. Right? That would also work. So now my variable of biggest number will have the value of whichever variable was larger. Right? So you can do that. That's okay. But, you know, it's not the most readable thing in the world. But if you're really comfortable, then yeah, definitely start writing like that if you're comfy. Questions on that? Okay, that's good. I don't want us to get too bogged down on the ternary, honestly. I want us to really kill these. If we can kill these, the ternary will come easy. Because it's just converting this concept into that. And this is a lot more flexible because we have else ifs. Ternary, there is no else if. All right? Cool. So let's comment that out. All right, so then we talked about loops. Loops. I'm going to erase this stuff. We're good? Yeah? Okay. So let's talk about the loops. All right. We learned 2 different loops. Yes?
Yes.
Which 2 do we learn?
Wow.
For and while. For while. Okay. Tell me about the for. What? Who says the better one?
That one is you less get
Okay, interesting. So that's a qualitative concept. Is the for loop the better loop? No, I don't think so. You might like it more, you might not. It's definitely not the better loop, but it's not the worst loop either. They're both loops. It's okay if you like it more, though. But I'm definitely not writing that on the board. What could I write? Yeah.
While only run while it's true.
Okay, so let's write the syntax of a while loop. So we say while truthy condition run code block. That's it, right? That's the only thing there really is to a while. Yeah. So now. So that's a great question. So she says, do I have to make an increment? Not necessarily. It depends on what I'm doing, right? I could just write, like, what if I wanted an infinite loop for whatever reason, just because I'm keeping track of time, maybe, or something, right? Then I could just write while true, and no increment needed. If I do want my while loop to end, which is, of course, quite common, there's going to have to be some type of step towards the end condition, right? Step towards end. Because we might not, but it might not necessarily be incrementing, right? Incrementing, our for loops are so far at least, but usually for loops are very numerical, right? It's going from one number to another number. That's how we've been doing it, I think, right? And while loops, we can do those too, of course, the same way. But a while loop, often when you're using while loops, it's not like number based. Sometimes it is, but usually it's while this variable is larger than this variable, we'll do something. Or while, like, let's say we had like a human variable, and it was like part of that human was whether or not they were running or not. And so that's a Boolean value. So we would say like while is running. Keep doing all this stuff, and then maybe they have an energy level and that depletes. And then once it depletes low enough, then we would turn that value to false, and then the while loop ends. Or
So you
something.
only learn an increment when you're doing the numbers.
Yeah, you can't, like, a lot of it is number based, but it doesn't have to be. That's like the point I'm trying to make. So, like, what do I mean when I say that, right? So if I had, we'll sit down to the bottom. So what if we had this variable called let, and I had is running, and I had that at true. And this is going to be kind of silly because I'm still going to end up using numbers, but it's not necessarily the exact way we. And I'll also have a variable called let energy, and our energy starts off at 100, whatever that is. Right now, I could say like while energy is greater than 5 run this loop, but maybe I don't want to. Maybe I say while is running, we can do stuff. So what does that stuff look like? Well, I could say, okay, if energy is, let's say, modulo 2 equal to 1. So, right, so if our energy is at an odd number, maybe we'll decrement our energy. Energy minus equals, are we familiar with that syntax? So minus equals by 5. And then I could say else if energy, I'll just do else. So like if it's even, we can do energy plus equals 2. And then I'll say like, hey, if energy is less than or equal to 0, we'll reassign as running to false. Right, so we're not like doing a straight like incrementation of our I, which is kind of what you alluded to in the step. And so we'll also, I'll console log our energy every time, so we can see how our energy goes. Console.log, and I can say energy, and I can run this loop. So command K, run it, and we'll see it's like having this, I think it's going infinite. That's because I'm incrementing by 2 instead of an odd number. So that's not going to work. Control C to exit an infinite loop. Right, because it starts off at 100, it goes to 102, 104, 106. So we'll just say plus 3. I mean, mathematically it should eventually take us down, right? We'll see. Maybe it won't. No, it did. So we can see our energy. It started off at 100, we went to 103, we went to 98, we went to 101, 96, 99, 94, 97, 92. Right? It's going all over the place. It's not like a clear step that we're doing, because we could be doing different things. So our while loop isn't so numeric. I mean, it is using numbers for our energy, but it's not strict like looking at the number to continue if we're running. We're updating whether or not we're running based off of an energy level, but the steps are different.
If you put the console log number in the last line on line 30, it won't make any difference, right?
It will make a difference because this effect will already have happened. So if I move, so in the last one, our first number was 100. If I move this down, our first number will be 103. Because the effect will have already happened. The effect will already have happened. If we read the code, right, it will say, hey, energy modulo 2 is equal to 1. No. Else statement will increment it by 3. So it's already 103 by the time it hits our console log. While prior, when our console log was up here, our energy was currently 100. Right? Code's always going to run top to bottom. Does that make sense? Okay. Questions on the while loop? Yeah, I'll slide all this. Yeah. Any other questions on that? All right, cool.
Okay, so hold on. Going back to that comment that I made.
Yep.
So it's a safe practice to put console log on top, or depending what you want to do.
Just depends what you want to do. Typically, console log is for the human. The machine could care less. Right? It's just printing something to the screen. So it's often a helpful thing to debug or to see where everything is at a certain place in the program. To the computer, console log does nothing. It's not reading it. Oh, it's fun that we're doing JavaScript. I'm so happy to be in the JavaScript world. Okay, let's talk about the for loop. What's the difference with our for loop? Yeah, Dan. There's 3 parts to the for loop. All right, I like that as a start. All right, so we say for. What's our 3 parts? Initialization. I like it. Initialization. Yeah. Condition. Yeah. Condition. Increment or decrement. I like that. I'm going to use a slightly different wording. I'm going to use step towards end. Because technically a for loop can still be used exactly like a while loop. So it doesn't necessarily have to always be a number. It often is. But the increment and decrement is a safe bet, but that implies, doesn't that imply like subtraction or addition? But you might want to be dividing as well or multiplying, things like that. But it's still, yeah, you can also think of it as increment and decrement, you'll be fine. Okay, and then we have the code block. Code block to repeat. Great, that looks pretty, seems pretty clear. Questions on that? Alright, so that's alright. We'll prove it to me. So let's tackle number 1. So work with somebody with you, or next to you, or you technically could work alone, but who wants to do that, right? Write a loop that sums all the numbers from 5 to 15 inclusive. So do it with a for loop, and then afterwards do it in a while loop. Let's try to do this in about 6 minutes. Okay? Totally good to talk.
Right. I'll do about 5 questions. Whatever you feel like.
Someone's telling you literally it's a similar package. Except number 5. I don't need to.
I agree with you. We have rational songs. So the way I was put it together yesterday, think of it as like a room in a room. Someone is telling you all so X to 5, X to 6, X to 7, 8. Someone who finds the sum of all that. And then you're putting an actual it's number 1 plus number 1 plus 1 plus number 1 plus 2 plus number 1 plus 3 plus number 1 plus 4, and so forth and so forth. I'm actually closing my bar. I should get up.
That is all control so specific.
All right, clap your hands once if you can hear my voice. Clap your hands 2 times if you can hear my voice. Awesome, I love it. With a thumb, give me some feedback. Yay, nay, okay. Okay, yeah, let's break it down even more. For loops, yay, nay, okay. All right, we're a little all over. And the while loop. It's so funny. Okay, that's all right. Let's do it. So we've got our little for loop here. So we know it's going to start with 4. So we're writing a loop that sums all the numbers. So what is sums? That means we're going to have the number 5, the number 6, the number 7, the number 8, 9, 10, etc. up to 15, including. So we're also going to need a variable to keep track of sum. I saw a lot of people go, let sum, and I saw a lot of people go like that, because that's the first number. How do we feel about that number? Isaiah, I see you shaking your head. How come?
Well, you started your loop at 5, and you start the sum at 5, it's going to set it off by 5.
It's going to double count 5, right? Totally. So if we do this, and then we start looping through all those numbers, and we say, all right, look at 5, and add our 5 to the sum. Well, then we've already got 10, but we've only should have 5. Does that make sense? So if we start our sum already at 5, and we start our loop also at 5, right? A lot of us let, here I'll just write the initialization. We're going to be double counting the 5. So what's a better value to start our sum with? 0, right? Because 0 is kind of like the absence of a number, but still a number. What? Yeah, that was your hint.
I got it.
Right, I saw more than just repeat to that, though. Okay, so then we have our first step in our for loop, which we have is our initialization. Great. Then we have our condition. What's our condition? Is there anyone having? I've heard from all of you. Cassidy? Haven't heard from you. Perfect. Thank you. I know I just called on you. I'm probably just going to keep doing that until we can get all the voices. Okay. I less than or equal to 15. Why? Phil? Yeah, because we want to stop at 15 and get to 15. So I could write it like that, yeah? Is that the same thing? Is that different? Why might I not want to write it like this? Doug?
If you don't have the comments up top and someone else created the code, they might not know why you wrote 16.
Right. Yeah, so it's a little bit less explicit to what's going on. Right? Is this technically wrong? No. Will I get the exact same result? Yeah. But is it as clear to read? No. Right? So that's kind of like the test. If you have a clearer way to write it that way. Also, you'll have less error along the way. You'll still have lots of errors though. Okay. Step towards the end. What's our step for this one? Someone new? Oh, Hidera? Increment? Yeah, right? So we can do I plus plus or I plus equals 1. I'm going to write it like this today because I want people to realize that it doesn't have to be by 1 in all situations. Okay, so then we got this. That looks good. Open up our code block. So it's like this is the stuff we want to run every time. What do I want to do? What do I want to run in here? Giovanni?
You want to run the sum of all the i's that's running in the loop.
Okay.
So you would write sum
Yeah.
plus equals I.
Plus equals I. I agree. Right, so sum right now is 0. And our first loop, I is going to be 5. And we're going to say, okay, we want the value of sum plus whatever the current I is at. So we're saying 0 plus 5 is now our sum. So we want sum's value to be reassigned to the value of 5. Okay, to write it on the board in the order that it's occurring. All right. So we have a little chart. We have sum right now is 0. We have I is 5. So we hit this line, and we say sum is now equal to 5. Or sum plus itself, plus 5, right? So that becomes 5. I gets incremented by 1. I becomes 6. We get the line again. Sum plus reassign sum's value to itself, which is 5, plus I, which is 6. Sum becomes 11. Right? 5 plus 6 is 11. I gets incremented by 1. I becomes 7. And we say sum equals sum. 11 plus the current I. So 11 plus 7, 18. Thank you. I gets incremented to 8. And we say, okay, sum plus or equal to itself plus that. So 18 plus 8, 26. Right? I gets incremented to 9. Is this making sense? Should I keep going or do you feel we get it? Okay, guys, I'm not going to do all of it. I think it goes to 110, right? Okay. I could. But big deal. All right, and then at the very end, let's console log sum. And check our math. Sorry? Oh, maybe. Okay, we did get 110. Okay, questions on this for loop? Yeah, Rafi.
Why did you put the console log outside those curly lines and not inside like the rest of the code?
Great question. Samantha?
So I should originally put it inside as well, and then because it's part of the loop, it'll console log like every different sum, right? I think.
That's right.
So if it's outside, then once the sum is complete, then it console logs.
Totally. So if we move our console log up here and run it, I get all of this stuff on the screen, which is okay, right? Especially for debugging purposes, but it's not the end result. So if someone just wants the sum, and this will really come in in handy when we get into like writing functions and you actually return something instead of just print something to the screen. We're only going to be able to return one thing. So there's never a situation where you have multiple returns from a function. So to replicate that kind of concept at this point, I'm only printing one thing. Make sense? Great question, though. Any other questions on this for loop? All right, so now the good stuff, right? Now the while loop. The while loop's crazy. So it's really not, and I will show you why. All right? This is what we currently have for our for loop. So let's make a while loop comparison. Well, we're going to still need a sum. True or false? True. Okay, so we're going to say let sum equal 0. Okay, so far, how's it feel? So far, it feels good, right? It's the same as the for loop. Okay, great. We're going to need to start at I somewhere, right? So we called it the initialization in the for loop. For the while loop, I'll say the initialization will go right before the while loop. So instead of having it in there, like in the for, I'll just write my I here. Right? Initialization outside of while loop. And I'll comment that. Initialization outside. Ay. Okay. So then, the next thing in our for loop is the condition, yes? All right. So we know the form of the while loop is while truthy condition. Seems like we should just write while. I think it's going to be the exact same condition, all right? While I is less than or equal to 15. Okay. And then the next thing in the for loop is the step. Well, there's no spot for it there, so we'll just add the step somewhere in the while loop. So let's put the step right away so we don't forget, and we just say I plus or equals 1. Right? This is essentially the same code, just shuffled around a little. Right? The initialization comes before the while loop. Inside of the parentheses is the condition, identical to that of the for loop. And then the last line of the while loop is the step that we said as the last argument of the for. That's it. The code inside is identical. So we can go here, just write sum plus equals I. Oops. And then here we'll log. Right? This is the same. Go back 110. It's not that different. It's just a slightly different format. Yeah, Maria.
Would it make a difference if you put the sum underneath the I plus or equals?
Great question. Will it make a difference if I put the sum underneath? Okay. Why?
Because it increments before it adds to the sum. So by the time it reaches sum, it'll now be, so like if we're going from here, it'll be 5. That 5 will have already turned into a 6 by the time.
Yeah, that's exactly right. Thank you, Jed. Let's walk through it. Let's walk through it the same way. Right, we have our sum. We've set it to 0. We have our I. We've set it to 5. Cool? All right, inside the while loop, still running top to bottom. All right, just going to then do it again. So if we have it up here, and we say I plus equals 1, what is I? Well, I is already 5. So I becomes 6, right? Because I just got assigned to itself plus 1. So here we go, I is 6. Sum plus or equals I. So sum plus itself plus I. So now sum is 6. So if you remember from last time, that's not how it started. So we're definitely already off to a bad start. Does that make sense? I'm going to keep going. So I gets incremented again by 1. So now it's at 7. 7 plus 6 for our sum. What? Now we're at 13, right? Before I think we were at 11. Right? So now we're at 2 off. So things aren't looking great. Right? I think by the end we'll be like 15 or 11. Oh, because it will be 1. Yeah, right? Every single time we're adding 1 extra. So that's not good. So instead of that, we want to write it like that. Because then sum is 0, I is 5, and we go sum plus or equals itself plus I. Sum is now 5. Then I gets incremented. 6. Make sense? Yeah.
So, if, for example, one of the problems I think on the lab with the it said exclusive. So if it said exclusive, we wouldn't include the original 5. We would increment it first because we wouldn't want to include the 5 and then.
So I'd have to see the exact wording. Often when things say exclusive, they're usually talking about like the last argument.
Oh.
So it probably would be not including 15, but it's possible they also can not include 5. I'm not sure if they said wrong. Other questions on that one? All right, great. So we get to test our skills again. Because I have a few of these. Oops. Don't look ahead. Okay, well, dang it. Okay, write a block that multiplies. So you can think of this as a factorial. Those of you who are into math, those of you who aren't, ignore that for now. Write a block that multiplies all the numbers from 9 to 1. So you can technically go in either direction. It could be 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1, or 1 times 2 times 3. Right? It doesn't matter the order you multiply numbers in. That's another fun math thing. All right, so you can work together. Let's do this in just 5 minutes. Oh my God. What? I'm sorry.
What if I did it all the way around? talking about debugging, I put that here. And then I can go back and run yeah, so what you're trying to do, you have to worry the sum of all numbers from 15. So that means the sum. So you're adding all the numbers that are 1. So you're adding 5. What are all the numbers? 5, 6, 7, 8, 9. So the sum of all, so all the numbers be 5. So you're writing down 5, 6, 7, 8, 9, 14. So now the sum of them. Sum means that right. So this one's going to be the same thing. Multiply one to 9. So now, right, so 9 times 8 So I did the same thing. I'm going to change this. It makes more sense. So X is 9 because you're going to start on Y. What's the condition you want to stop? Right, so X has to be greater than or equal to 1. And then I'm going down. So X minus 1. So what I want to do is find a product with multiply X by the next number that's 100. So if the product is 9, so the next number 100 is 8. So you're doing that as an 8.
So, we started with the product. What is the sum, right? Correct. We started at 1 because when you multiply something with 0, it's not 0. So you don't want to use it. Alright? Because they asked us for multiple. Correct. So, after you said that, you want to mix it all together. So, this one, where do you want to start? Just where you want to start, right? So, it's 4. Next, 9, which is where you want to start. I got 4. This is 1, 0, 2. I see now. Okay, see now with this one. Where? I see that everything's going to be between. So between 2 and this. So.
All right, let's try it out. Clap your hands once if you can hear my voice.
Clap your hands.
Clap your hands once if you can hear my voice. Can you hear me? Can you see me? All right, anyway. So, with the thumbs, how do we do? Yay, nay, okay. All right, so we did, it looks like we did fairly a bit better this time. So let's actually talk about it. And we can use our old answer as a bit of a guide. Right? So we're asked, hey, we want to write a block that multiplies all the numbers from 9 to 1. So this is essentially called a factorial question. Or, and slash, when I say multiplies, right, all those numbers together, that is called a, do we know? when you take a number times a number, what is that combo called? Product. Yeah. So we're actually trying to get the product of all these numbers. So instead of my sum starting at 0, what's a really good product to start at? Divine. Why 1? Yeah, but then why 1?
I was thinking, so anytime it goes into the loop, you take the loop times one, and then use the number that you want.
Yeah, exactly. So, right. So anything times 1 is anything. Agree, disagree? Right, this is the same as like when we were doing our sum, we could do anything plus 0 is anything. So the goal is that after that, for that very first number, we want whatever that anything is. So we can start our product at 1, and we'll start with our for loop. So we say for, and then we have our initialization. Where do we start? The feed?
So I would start with x equals 9.
Okay, so I'm gonna use I, because I is the standard when you're doing this. So I encourage you to also use I. If you write X and people look at your code, they'll think you're doing something weird. They won't know why you're using X. If you use I, they'll go like, that's normal. Although technically, what Rafid's saying, like X works, right? It's it's like the code culture. It's kind of like standard. I is short for index. A lot of the time, you use that number to see something in a string or an array, which we'll learn this weekend. And so it's just kind of I is short. It's just what they use in for loops. So you're almost always going to say I. So we say I starts at where, Rafid?
9.
So we're going to start at 9. So I guess we're going to work our way down. That sounds great. So we'll say while. What's our condition? Who can help me with our condition? Anyone I haven't heard from? Danny, haven't heard from you yet. What's our ending condition? Okay, cool. So he said while 9 is greater than or equal to 1. So if we say that, will 9 ever be less than 1? No. So because that's just straight up the number, right? So instead of using 9, we can use I. We can use I. So if we say while I is greater than or equal to 1, or greater than 0, right? And then our step towards the end, what do we think? All right, Andrew.
I mean, if you're going down, it's going to be I subtract equals.
Okay, right. So we're going to I minus minus, or we can say I equals I minus 1. We can do whatever we want, right? Anything to reassign the value of I to be 1 less. So that looks good. And then we're writing our block of code. So last time we were just doing sum plus equals I. What are we doing this time? Eric? Yeah? Yeah, right? This one's just product times equal I. So no drastic changes. I heard some people say like, why you can use times equals? I thought it's just plus equals or minus equals. You can do it with any of those math operators, right? So you can have divide equals, you can have modulo equals, you can have times equals, any of those are fine. All that's doing is like this side, this is equal to this operator, that. That's all. That's how that's breaking down every time. This is just syntactic sugar for these words. All right. To make it really uber clear, we can do product is equal to product times I. Right? That's same. It's the exact same statement. And then down here, we're just going to console.log our I, or our product. My mistake. And we should get a really big number. And we do, right? We get this enormous number. That 110, I guess I didn't console log. Did I not? I don't know where that 110 came from. Well, it's in there from something, but yeah. Something is not commented out, but that's all right. It's the 36 big number. Questions on how we're doing that? All right, so let's do it with a while loop. So just like before, right, we have to set it up. So we're still going to need our product, right? So we'll still say let prod equals 1. Let me comment this one out. So far we're the same. Where does initialization happen in a while loop? Before the while loop, right? So I'll just say let I equal 9. And then where's the condition go in a while loop? In the parentheses. So I'll say while I is greater than or equal to 1. Where's the step towards the end condition go in the while loop? Where does our step towards the end go in the while loop? Yeah, it goes in as the last line, right? So I'll just say I equals I minus 1. Then the code block goes in between. So it's the exact same. Prod equals prod times I. And then at the end, we can just console.log prod. All right? Not too many differences. It freaked out. Let I has already been declared. So there's somewhere that has some stuff there. All right, that's what that error means. It says like, hey, I already declared it. I already said let I somewhere. So that's why I knew it was higher up in here. What? That's right. I have to save it. And now we get our big number again. So there's nothing really wrong with the code, just wrong with our naming. Questions on the while or the for loop there? Yeah?
No, I'm telling you, but is there a reason why things give you, is it because like when you rename it like inside the loop, it doesn't notice? Because when you ran it before, that ran just fine.
Ah,
On the 110 printed.
really cool question. Okay. So Jay says, well, when we were declaring it before with the for loop, it was all cool, right? But now it's not. He's saying, what's going on? Oh, wait, we got some guesses. Yeah, Daniel.
With the for loop, it's inside the curly braces, so it was only like it only was recognized inside of the curly braces, but with the while loop, since we declared it outside, it got off.
Totally. So Danielle is saying, when we're doing it the for loop, it's being declared inside of that block. I don't know if you guys remember, and I said like block scoped. So as soon as you go inside of a scope, that's inside of a block. It's inside of that realm. Anything outside. So the while loop. This is our while loop block, right? It goes from here to here, right? Line 129. I can't. I'm better at my hands. Right? From here to here. So everything here, it can all see I, because this is inside, and so anything as we go deeper in still has access to things that are out there. However, if we had declared I here, which wouldn't have really worked for the while loop, because we have to keep reassigning it, but then it would just be inside of here. So at the for loop, it's in a smaller section. It's a scoping thing. We'll definitely see more of that. It's okay if it's not fully, you don't fully understand that, but if you do, that's great. We'll talk more. We will talk more about scoping. I just want to nail down loops today. Any other questions on the loops? All right, cool. So we'll go to our next question. So write a loop that prints all the numbers from 1 to 20, and your loop should end prematurely when it hits 17. So what does that mean? But I don't want you to make your loop only go to 17. I want it to act like it's going to go to 20, but then prematurely end.
Just stop at 17, or just
I want it to stop,
skip 7.
escape at 17. Yeah.
Skip 7.
I want us to get out of the loop when we hit 17. If I give any more hints, you'll know what it is. Work on that. I think we can do like 4 minutes for that.
I'm just gonna do it first, what I know, like just out of all the That's what she just said. It's like, you know how much numbers? Yeah, well, I was waiting for the assignment and like, I think it was like, I was 30 pages in the essay, and I didn't do it. I was in the library and I was like, oh my god, he started laughing, I was like, yo, what? So I was like, I need to share that with people, because y'all can see it. That, if that number existed, yo, that would be bad.
I didn't try it yet, because I didn't console or anything, so. Yeah. If I had all my information, I would have decided. Okay.
All right, let's check this out. Clap your hands once if you can hear my voice. Clap your hands twice if you can hear my voice. All right, I'm seeing a couple of interesting things from a lot of us, which we'll correct. But for the most part, I'm seeing pretty good work. Yay, nay, okay on this one. Give me a thumbs up if you knew to use break. Break. Okay, fine. Pretty good overall. So let's walk through this. Can somebody walk me through it? Help me. Somebody I haven't heard from yet. Sorry, repeat. It's not personal. Yeah, Crystal, I haven't heard from you. And you kind of raised your hand. All right, let's do it. Okay. So we're gonna use I, because that is the standard. But we can keep going. Let I
Yes, let I
equal
equal 1.
to 1. Okay.
Okay, then it's going to be I is less than or equal to 20.
Less than or equal to 20.
And then we can do I plus or I plus equal to 1.
Okay. I like it. Thank you. I like the options. Okay. Great. So, right, this is our question.
I was going to say, before, like, the last problem, we initialize let pi equal 1, and then underneath that we did for let I equals 9. What's the difference between these two? Like, let pi equal 1 and let I equals 9.
What is it? So product was a variable that we were keeping track of and going to continue to update. So we had that outside of our loop so that we could keep updating it. If we declare a variable inside of a loop, it's going to keep getting redeclared. And the I equals 9, we were starting at 9 because we were trying to find the product of all numbers between 9 and 1, or 9 factorial. Okay, so because we're just going from 1 to 20 on this one, I is starting at 1, and it's ending when it hits to 20. So it says, hey, we want to print every number. All right. So what's the first line of this block? Right, we want a console log, right? Console.log I. So we're going to be printing every single number. So if this is all the code I wrote, I'd be off to a pretty good start because I'm getting almost everything. Right. However, I asked you to prematurely end it. So how do I write that one? Patrick. A break? Yeah, give me a little bit more on that. If I just write break, I think we're only going to write 1.
I.
Hang on. Go for it. You're good. Look at your code. Yeah, I know you got it right. Okay, so we say, hey, if I triple equals 17, yeah, then break. Okay, I like that. So I saw a lot of us write it like this. I saw a lot of that from like a lot of people. So this is like, it will run. It's not attractive syntactically, right? If you open up curly braces, the contents of that curly braces should have its own line and should be tabbed in. All right? This is how I want it written. Always. That said, if you must write it on one line, if this is the dream, I need to write this on one line, then when you do that, you omit the curly braces and you can just write break. Celine. Yeah, it still works. What? Yes. If it's on the same line, you don't need the curly braces. If it's on the next line, you do. Okay? Yeah.
I don't know if this is a dumb question, but like,
No dumb questions.
you're asking us to print numbers from 1 through 20. When you break it at 17, you're not even printing 18, 19, 20.
That's
So I'm
right.
not just ask the computer to model numbers from 1 to 17.
Great question. So Rafid says, hey, why not just drop this line and adjust this to 17? Yeah, 100% would work. This is a fictitious example of break, right? So this is just to practice using break and understanding how break is going to influence our code. In real life, if someone asked you to print from 1 to 17, please don't use break, right? Just print, make it 17. But there will be other times when you will want to break. Like if I was searching through something that had lots of numbers, and as soon as I found the number I wanted and know that it existed, why would I keep iterating through it? I would break out. We will do it eventually. Ashia.
I don't understand why it didn't include the number 17, because the way I wrote it is I wrote the if statement first, break, and then I consume it, and it gave me the numbers up until 16, but it still stopped at 17.
Yeah. Right, so that would happen. So Ashia says, hey, I did mine in this order. And so instead of it saying 17, it's only going to go to 16. Right? This is order of events. So loop runs, I starts at 1. All right, for fun, let's pretend this is at 3, because I don't want to go all the way up to 17. Okay? So, let's look at our table. I is 0. Yes? Next line of code is line 65, and it says, 165, whatever, and it says, hey, is this equal to 3? And it says no. So it prints I. So we get our I as up to 1. Sorry, I is 1. We okay?
Yeah.
Okay. All right. Then the loop ends. I gets incremented by 1. I becomes 2. So we say, hey, okay, is I equal to 3? No. So go ahead and print Ri. And then we increment I. So I becomes 3. And then it says, hey, is I equal to 3? Yeah, so it breaks. If it was the other way, it goes, I is 3, first line of our code is print our I. Then it goes, hey, is I equal to 3? Yeah, all right, now that's the difference. Not such a big deal. Let's do this as a while loop, yeah? Might as well. Where do we initialize? Outside. Okay, so we'll say let I equal to 1 while. Now what? Yeah, the condition, right? So I less than or equal to 20. Open curly block. And then what's our step towards the end? Increment. So I'll say I plus equals 1. I'll write all our code in here. What do I want to do? Yeah, console.log I. If I, in this situation, I guess I'm doing 3 to keep it the same. Or I really would rather everybody for now to write like that until you really feel super comfortable. What? Right, so now we have, it's essentially identical code, right? Am I? Thank you. And so it still works. Pretty cool. I am missing an equal sign. There is a difference. Still works. Some of us might be wondering what that difference is. We can go over that. Just to give you like a quick thing. So if I have a string of 3, oops, and I say that's equal to the number 3, is this going to be true or false? False. Because it should be, right? Because the string of 3 is not the same as the number 3. I agree. So the reason, and this is why we teach you to use triple equals, because it's consistent to what we believe it should be. If we were to use double equals, we'll actually get true. So when you use double equals, it does something called type conversion to see if it can try to make it work for you. So for all intents and purposes, from here on until you're a JavaScript master, let's just keep using triple equals. And keep calling me out if I do double equals, because I'm doing it by mistake. I also will only be using triple equals. Okay? Cool. Let's go to the next problem. So I want you to write a loop that iterates from 0 to 100, and then do it again with a while loop. Oh, I mean 100, from 100 to 0, downwards. Okay? Let's do that in 3 minutes.
first for the whole of the wild loop, the first time I did it, I kind of did good people. I did the wild, the condition, initialization, I did the wild, then I did minus minus. Then I did so why is that when I do like this? First time I did
Right, so you see that it's peak coverage. Why it's peak coverage? Because the first time you put the
it reads as 2 minus 1, so it starts.
Yeah, but here instead of code block, you're instead of writing code block, you're just writing function, which is the same. It's the code system.
What do we got?
What?
No, you don't have to erase anything.
No, he wasn't getting like what was a code block, and I told him like this is like also log in the for loop.
Nice. All right, that's been at least 3 minutes. Clap your hands once if you can hear my voice. Clap your hands twice if you can hear my voice. Yay, nay, okay? Okay, hopefully we got yays on this. If this is a nay, definitely we got to do a lot more practice on these. Like I would just do these constantly this weekend that we have. So let's quickly talk about. Let's do our for loop. We say let I. We're doing our initialization. Where should I start? 100, right? Some people, right? The point of this one, some people said this felt like a trick because they really felt like we weren't doing anything new. What we're doing new is just that we're iterating backwards. You'd be surprised by how many people, if they've only iterated forwards 1,000 times, when it comes to iterating backwards, it's like I don't know how I would do that. And it's like, well, it's the same. It's the exact same thing. So that's the point that this was trying to get across. So we say, well, I is greater than or equal to 0 this time. Whoops. And we can do I minus minus console.log I. Yep. Questions on that? Let's do our while loop equivalent. Someone want to help me with that one? All right, you're going to do it? Let's do it. Let I. Okay. Yep. Greater than or equal to 0. Right? If we do less, then it's going to skip the while loop entirely. Sure. Yeah. Right? It's the same stuff. It's just shuffled around a little bit. If we run it, we'll see two things of what I typed in something else. Two instances of it going from 100 to 0. Right? Hopefully, it was relatively straightforward. Okay, let's do a slightly more complicated one. Update this previous loop to print only numbers that are divisible by 3 and 5, and numbers that are divisible by 9 should instead print crazy 9s. What? So if it's divisible by 9, I only want it to print crazy 9s. Otherwise, if it's divisible by 3 and 5, I want it to print that number. Okay? All right. Let's work on that for about 5-10 minutes.
Yeah, no, I'm gonna hear this.
This is why.
All right, clap your hands once if you can hear my voice. Clap your hands twice if you can hear my voice. All right. Yay, nay, okay. Trying to get some overall room feedback. All right, okay. Part of the hard part was This question's not 100% clear what it's asking, right? If you didn't find it 100% clear, you should ask the question, right? So there's like a little hidden lesson in there too, right? I recognize this isn't the bestly written question. You should always clarify, right? If you're at an interview and somebody asks you to program something and you don't really know what they're asking, 100% you should clarify. Do not assume that you know what they're asking. Even if you think you know what they're asking, just double check. Say like, oh, so if I'm given this, like what should 45 print out, right? 45 is divisible by 3, 5, and 9. I know it says instead print crazy 9s. Does that mean I shouldn't print the number 45 and I should just print crazy 9s? Or should I be printing both? I'm going to assume that I'm only